Use tabulated half-cell potentials to calculate delta G for the following reaction. Is the reaction spontaneous? So I've underlined the half cell because that means that we're going to need to find what? Oxidation and reduction. So which element or compound is oxidized? Well, I've got the sodium. It goes from 0 to +2. Ding, ding, ding. That would be my oxidation. Remember, you need to add electrons to the more positive side. So in this case, that's going to be the right-hand side. So I'm going to get 2Na plus, and then I'm going to add 2 electrons. For the reduction, I need to look at the water because it's the only thing that I haven't used. It just so happens it is the more positive side. So I'm going to go ahead and add my electrons on the left. That's going to go to hydrogen gas plus hydroxide ions. So now what am I going to do? Well, if you recall from earlier, we found the electropotential of the cell, and we said that was equal to the electropotential of the one that was oxidation plus the reduction. And then I'm going to go and find those values on the standard electrode potential at 25 degrees C. Remember, the oxidation is the opposite of the reduction. So when I did the Na one, I found it to be minus 2.71. And then when I looked up the water, it said it was minus 0.83. So when I do that calculation, I get a positive 1.88 volts. Now remember, you do need to write that positive sign just to indicate that you know that it is a positive versus a negative. But you know, the problem didn't ask for the E of the cell, it asked for that delta G. And we have a formula for that. So delta G equals minus N times F times E for the cell. Now, what is N? Well, N is the number of moles of electrons that we have. So how many did we have? We had 2. So I have opposite of 2 moles of electrons. Now what is F? Well, F is Faraday's constant, which is 96,485 C over moles times electrons. And then we just found the cell up here, except I need for the units to cancel out. So that's going to be changed to what? Well, we know that volts is the same thing as joules over C. So when I do that, now what cancels? Well, I've got the C's go away, the moles of E and the moles of E, which leaves me with the J, which is what we want, correct? So I'm going to get minus 362,783.6 joules, but you only want how many significant figures? It's kind of iffy on this one, right? Well, up here, this one has 2, and this one has 3, so I'm going to need 2. So I'm going to get minus 3.6 times 10 to the 5th joules. Now, that's not the whole thing, right? It says, is the reaction spontaneous? Well, remember, it's negative, so yes, it is spontaneous.